Hi everyone. Before we start our presentation, I want everyone to try something for us. Close your eyes and rub them for about 5 seconds. Okay, you can open them now. If you saw something like this, raise your hand. What you have experienced is a visual phenomenon called phosphenes, which is what we'll be talking to you guys about today.
First off, we'll give you guys a more detailed explanation of what the phenomenon is, followed by why it's so interesting, and after that, we'll go over some possible reasons why phosphenes occur. Finally, we'll share an experiment that can be run to get a deeper understanding of this visual phenomenon. So, a description of the phenomenon is that the phosphenes phenomenon is also known as seeing stars. Light appears without any external source and may show up as flashes, dots, or squiggles. These phosphenes are commonly experienced when we rub our eyes or apply pressure to them. However, they can also be triggered by an electrical stimulation to the brain.
It's important to note that they can also be a symptom of a deeper neurological disorder or an eye condition, such as a retinal detachment where people notice flashes with their eyes closed.
What's puzzling about this phenomenon? Phosphenes are internally generated. Even in the absence of external light, our eyes and retinas continue to interpret the presence of illumination. Our brains engage in the same neurological processes as if we were seeing something, despite the absence of an actual light source. Photoreceptor cells in the eyes convert the light into electrical energy even when photons aren't triggering the typical action potential change. Differences in visual experiences prompt the question, what role do psychological and anatomical factors play in shaping how we perceive phosphenes? Astronauts have also reported experiencing phosphenes. These light flashes are related to high energy particles in space and were most commonly reported before sleep.
Why do phosphenes occur? Phosphenes occur due to the hyperpolarization of the retina in the absence of light. This occurs due to different types of stimulations, and which are as following: mechanical, electrical, chemical, through hypoxia, neuronal activity, and pathological causes. Now, reasonable hypothesis for our experiment. For this project, we will be covering mechanical stimulation to showcase phosphenes, and our hypothesis is as follows. Gentle pressure applied to closed eyelids will induce the perception of phosphenes, characterized by observable patterns of light and color resulting from the direct mechanical stimulation of the retinal cells. Rationale of the hypothesis. This hypothesis is based on the understanding that mechanical eye stimulation, which is rubbing the closed eyelids, can exert pressure on the retina, which is responsible converting light into neural signals, and when stimulated mechanically, produces a similar neural signal in the absence of actual light, which results in perception of light or patterns known as phosphenes.
A possible experiment. So the purpose of our possible experiment would be, as mentioned, to examine the hypothesis that mechanical eye stimulation can exert pressure on the retina, which causes hyperpolarization, without photons being the original source. So the method for this would be to have healthy, non-visually impaired adults be divided into 3 main groups. Group 1 being the control group, in which participants are exposed to a plain striped image so as to activate both the rods and the cones. Group 2 would have adults exposed to light eye pressure, and Group 3 would have adults exposed to heavy eye pressure. Then we would compare the firing of neurons utilizing the input from the participants on whether they experienced vision, and also using EEG and fMRI technology to examine if the same neurons are firing in the visual cortex. The independent variables the independent variable is the pressure that's being applied to the eye, and the dependent variables are the occurrence of phosphenes measured through the input from the participants in imaging techniques, as shown here, such as an fMRI.
Some of the controlled variables would be participants' characteristics such as age, gender, and their current situation in terms of visual impairments, and also an experimental environment and duration of pressure, and based on how well they follow the instructions. So these are also potentially confounding variables. So based on the amounts of force they put, it can give them a different results. And based on everyone's different genetics, it could be more sensitive to certain individuals compared to others. And at the same time, the environment, based on how much light there is, it can also like affect the quality of the visual phenomenon of phosphenes. And for a simplified experiment that you or say a sibling at home can even try is just to sit comfortably and just close your eyes and spend a few moments just imagining colorful pictures or shapes with your eyes closed. And after that, usually wait within like 10 seconds before moving on to the next step. And use your hands to gently press on your closed eyes. And after a while, when you remove your hands, just wait a bit and see what you're noticing. So you may even notice colors, dots, or shapes. And that is phosphenes. Thank you for watching. Here are some resources. And that concludes our presentation.